Okay, so this is Unit 7, Lesson 1, Arithmetic and Geometric Sequences and Recursive Formulas. An arithmetic sequence is a list of numbers in which the consecutive terms have what we call a common difference, and we refer to that as D. That common difference is found by subtracting your next term minus your previous term. So here in this sequence, 3, 8, 13, 18, 23, you would subtract 8 minus 3, which is 5, and that would give you your common difference. But you want to make sure that all of them give you that difference. So you want to go through the list and ask yourself, is 8 minus 3 the same thing as 13 minus 8? And is that the same thing as 18 minus 13, which is the same thing as 23 minus 18? And it is. Okay? So you always subtract in that order, next minus previous. So when you look at this list, you do the same thing. You're going to subtract, saying this is your previous term. This would be your next one. So you're going to say 25 minus 29, which is going to give you a negative 4, but you want to make sure that you're going to get a negative 4 every time you subtract. So go to here and ask yourself, will 21 minus 25 give you the same thing as 17 minus 21, which is the same thing as 13 minus 17? And it is. They all give you negative 4. So really this is called a common difference because of the way that you subtract, but really what it ends up being is the number that you would add each time to get the next term. For instance, I'm going to add 5 to get 8. I'm going to add 5 to get 13, add 5 again to get 18, add 5 again to get 23. Okay, same thing here. I would, to get from 29 to 25, I would add a negative 4. From 25 to 21, I would add a negative 4, and so on. Okay. Here, you're going to say x plus y, subtract x. That gives you a common difference of y. And you just want to make sure you would get that each time. So here, if I did, so we just subtracted those. Now I'm going to subtract these. X plus 2y minus, make sure you put this in parentheses, a quantity of x plus y. So that gives you x plus 2y minus x minus y. X's cancel. 2y minus y leaves you with y. So you are going to get that common difference of y every time. Okay? So that is an arithmetic sequence. Now, we also have a geometric sequence, and that is when your list of numbers, the consecutive terms, have a common ratio or quotient. Ratio and quotient means the same thing, and we call that R. And you get that by dividing in this order, your next divided by previous. So here with this list of numbers, my common ratio would be 8 divided by 2, which is 4. But you want to go through the list and you want to make sure you're going to get that 4 every time. 32 divided by 8 is 4. 128 divided by 32 is 4. So you do get it every time. Here, you're going to divide in this order. 27 divided by negative 81, which is actually a negative 1/3. So be careful, don't accidentally call that a negative 3. But you want to make sure that negative 9 divided by 27 is going to give you the same thing, and that 3 divided by negative 9 will give you that negative 1/3, as well as negative 1 divided by 3. And they do, they all give you the negative 1/3. So again, it's called a common ratio or quotient, but it's really the number that you're multiplying by each time to get to the next term. So 2 times 4 gives me 8. 8 times 4 gives me 32. 32 times 4 gives me 128. Same thing here. If I were going to do negative 81 times negative 1/3, I would get 27. 27 times negative 1/3, I would get negative 9, and so on. Okay. Here, you're dividing the same way. Your next term divided by your previous term, so xy divided by x, leaves us with a common ratio of y, but you do want to make sure you get that every time. So you're going to do xy squared divided by xy, leaves you with y. xy cubed divided by xy squared. That leaves you with y as well. Okay? So that is your geometric. Alright? Now, when we talk about sequences, we say that our first term of a sequence is referred to as a sub 1. Some textbooks will call that t sub 1. I've even seen some of it called, some textbooks call it u sub 1. It doesn't really matter what the variable is. I'm going to use a sub 1 because that's what your state test is going to use. So your second term would be a sub 2. Your third one would be a sub 3. And then on out to what we refer to as the nth term. And that just means ever how far your sequence is going to go, your last term, so to speak. And we just refer to that as a sub n. Okay? Now, if you have a explicit formula, okay, for a sequence, then it will look like this. A sub n equals n cubed minus 3. What an explicit formula tells us is it'll tell us the number of the term in a sequence. For instance, if I want to know the first term, well, that's a sub 1. So what I do is I put a 1 in the place of n right here, which means I have to put a 1 in the place of n here as well. And so what I'm figuring out right here is that my first term is going to be 0. If I want to know my second term, I just put 2 in the place of n here, which means I have to put 2 in the place of n here. So my second term is 7, and then my third one, and so on. Okay, so my next one is going to be 26. Alright, so if I want to know the 8th one, I would just say 8 cubed minus 1 and figure out what that is. I'll let you do that. You probably have a calculator handy. I don't. If I want to know the 100th term, I would put 100 in the place of n. Okay? And then figure that one out. Okay? Is this sequence arithmetic, geometric, or neither? Well, look at these terms right here. Those terms are 0, 7, 26. I didn't find the fourth term, but I could easily find the fourth term by doing 4 cubed minus 1, which is 63. Okay, and so looking at these numbers, I can tell that it's not arithmetic or geometric because 7 minus 0 gives me 7, 26 minus 7 is 19. I'm not getting the same number. And then division by 0, I can't do that. 7 divided by 0 would not be the same thing as 26 divided by 7. So this is actually a neither. So not all sequences are going to be arithmetic or geometric. Alright, so some formulas for the nth term of a sequence that you need to know. If you want to write a formula for an arithmetic sequence, then you're going to use this equation. A sub n is equal to a sub 1 plus n minus 1 times d, where of course a sub n is the nth term, a sub 1 is the first term, n is the number of the term that you're looking for, and d is your common difference. So make sure that you know this formula right here for an arithmetic sequence. And then for a geometric sequence, it would be a sub n is equal to a sub 1 times r raised to the n minus 1. So right here, n minus 1 is an exponent. The whole thing is. And again, a sub n is your nth term, a sub 1 is your first term. R will be your common ratio, and n is still the number of the term that you're looking for. So, let me show you what I'm talking about here. Okay? Let's say I want you to find a formula for the nth term of this sequence. Then we're going to use that formula to find the 100th term, because I really don't want to take this sequence out to 100 terms. Okay? So, what I'm going to do there is I'm going to start with my formula. A sub n is equal to a sub 1 plus n minus 1 times d. And I need to back up and tell you why I need to use this one. you do need to figure out if this is arithmetic or geometric first. And I did that really fast in my head. But I can tell because 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3. So I can tell that this is arithmetic and that I have a common difference of 3. Okay? So once you decide that it is arithmetic, then write down your formula, and then we're going to fill in what we know. Now, I want a formula for the nth term. That means n is going to stay in my formula. I'm not going to substitute anything for n. Okay? So this is going to stay as a sub n. Alright? A sub 1 is my first term. Well, that would be 4. So I'm going to put 4 right here. Remember, we're going to leave this in terms of n because this is a formula that will help us to find the nth term, whatever n is. Okay? And then d is going to be 3. Alright? So I plug that stuff in and I just simplify. So a sub n is equal to 4 plus 3n minus 3. And when I simplify and combine my like terms, I have a sub n is equal to 1 plus 3n, or 3n plus 1, either way you want to write it. So this is my formula that will give me any term in this sequence that I want. Well, I want the 100th term. So if I want the 100th term, then I'm going to take this formula, and in the place of n, I'm going to put 100. And I am going to simplify. So a sub 100, the 100th term would be 301. Alright, now we're going to do the same thing for this one. Find a formula for this sequence, then find the 6th term. So again, you've got to figure out, well, what kind of sequence do you have? Okay? So I'm going to figure this one out by trying to divide, because I can tell I can't add or subtract the same thing every time and get these numbers. So you can use your calculator and divide 32.8 divided by 164, and then take the 6.56 and divide it by 32.8, and take the 1.312 and divide it by 6.56, and see if you get the same thing every time, and you actually do, or you should, if you did it right, you should get 0.2, okay? So that is actually your common ratio right there. That is your R, okay? So that means that this is geometric. Well, because it's geometric, I'm going to use my formula for geometric sequence, which is a sub n is equal to a sub 1 times r raised to the n minus 1. And again, I'm going to leave my n's in there because I'm looking for a formula for the nth term. And I didn't write that here, but it is the same directions as what we had right here. We're looking for the nth term of our sequence. So I'm going to leave the n's in place. Alright, so this is going to be a sub n is equal to a sub 1, which is my first term, 164, times r, which is 0.2, raised to the n minus 1. Okay, that is your formula. I'm going to make that prettier right there. There we go. So this is your formula, but we are going to get this into a different form. We're going to get this into the form of an exponential function, because the geometric sequence graphs in exponential function. I'll show you what I'm talking about. Okay, so what I'm going to do here is I'm going to say that a sub n is equal to 164 times, I'm going to split this exponent right here and say that it's times 0.2 raised to the n divided by 0.2 raised to the first power. That's because your law of exponents says that if you're dividing like bases, you subtract your exponents. So 0.2 raised to the n minus 1 is the same thing as 0.2 to the n divided by 0.2 raised to the first power. Okay? So when I divide this out, the 0.2n is going to stay in the problem, but I'm going to divide out 164 divided by 0.2. And when you divide those out, you get 820, and then I'm going to multiply that by the 0.2 raised to the n. And that's what gives me an exponential function, because now this is in the form of y is equal to a times b raised to the x, which is exactly what an exponential function looks like. Okay? Now I need to back up to number 6 because we're going to really look at how an arithmetic sequence will graph a linear function. Okay? If you compare your linear function y equals mx plus b to this function, your y is actually your a sub n, m is your common difference of 3, x is your n, and then your y-intercept is actually 1. That's because you can write this in a table if you had n, which is the number of your term, and a sub n, which is the actual term, okay, then we can make a table looking at this list saying that our first term is 4, our second term is 7, our third term is 10, our fourth term is 13. So when you compare this to x's and y's, your n would be like your x, and your a sub n would be like your y, because here y depends on x. Well, in a sequence, a sub n, your actual term, depends on n, which is the number of term. Okay? Now for this one right here, it says to find a formula for this sequence. Well, again, I'm going to try to figure out, what kind of sequence is this? Well, if I start subtracting, if I say 4 minus 1, that's 3. 9 minus 4 is 5. Well, I'm not getting a common difference. So I'm going to try to divide. If I say 4 divided by 1, that's 4. 9 divided by 4, that's going to be 2 with 1 left over. I'm not getting the same common ratio. So this sequence is actually a neither sequence. Okay? And we don't have a formula for that. That means you have to think a little bit harder. You have to think about, well, what's going on? Well, sometimes if you make a table, n and a sub n, then you can figure it out. You can say, well, the first term is 1, and the second term is 4, the third term is 9, the fourth term is 16, the fifth term is 25, and then so on. So what you're doing is you're asking yourself, well, how does this n relate to what I get for a sub n? Well, if you look at these numbers and you square them, then you actually get these numbers. 1 squared is 1, 2 squared, 2 squared is 4, 3 squared is 9, and so on. Okay? So what you've got here is this is your your a sub n, whereas this is your n. So in order for you to get a sub n, you have to take n and square it. So this is your formula right here. Okay. Let me see. Number 9. How many terms are in the arithmetic sequence? Okay. So we have this sequence. It starts at 12. It goes to 19. And then we don't know the terms in between, but we know it ends at 124. So this is what I know, is that this is a sub 1. And this is my last term, a sub n. Well, the question says how many terms. That means what is n. We don't know how many terms there are. Okay? So we're going to figure this out by using our formula for an arithmetic sequence, that a sub n is equal to a sub 1 plus n minus 1 times d. Okay? So a sub n, okay, is 124. That's my last term. A sub 1 is 12. That's my first term. N is what we're looking for, so I'm going to leave that right there. And D is the difference. I can get my difference from right here. I can say 19 minus 12 gives me a difference of 7. So now I've got an equation that I can solve for n, and that'll tell me how many terms is in here. So I'm going to solve this. And when I solve this, it tells me that this particular sequence would have 17 terms. Okay, so that is how we use explicit formulas. Now, let's talk about a different kind of formula for geometric and arithmetic, and that is called a recursive formula. That's R-E-C-U-R-S-I-V-E, recursive definition. It consists of two parts: an initial condition that tells you where you're going to start, that would be a number, and then a recursive formula that tells you how any term in the sequence is related to the previous term. Okay, so this is a recursive formula in which this is my initial condition that tells me where I'm going to start, and then this is the formula that relates the next term to its previous term. So a sub n would be our next term, whereas a sub n minus 1, the n minus 1 means the term before that. So that's your previous term. So it says find the next 3 terms in the sequence. So all I have to do is, I know what a sub 1 is. So if I want to find a sub 2, then I'm going to put 2 in the place of n here and here. So a sub 2 is equal to a sub 2 minus 1 plus 4. So a sub 2 is equal to 2 minus 1 is 1. So that becomes a sub 1 plus 4. So a sub 2 is equal to a sub 1, which is 3, plus 4. So that means that a sub 2 must be 7. So now when I want to go to find a sub 3, well, that means I'm putting 3 right here in the place of n. That means I have to put it in the place of n right there as well. So that's going to be a sub 3 minus 1 plus 4. So that's a sub 3 is equal to a sub 2 plus 4. So a sub 3 is equal to a sub 2, which we just found to be 7, plus 4. So a sub 3 is 11. Okay? So to find the next 3 terms, so let's find one more. A sub 4. So that means in the place of n right here, I'm going to put 4. In the place of n here, I also put 4. So that gives me a sub 4 is equal to a sub 3 plus 4. And a sub 3, we just found that to be 11. And then 11 plus 4 gives me 15. So my sequence so far, my first term is 3, and then the next one is 7, and then 11, and then 15, and it's going to keep on going like that, okay? So we found the next 3 terms. Now it says write an explicit formula. So that means to use the a sub n is equal to a sub 1 plus n minus 1 times d. Okay? So my explicit formula, a sub n is equal to a sub 1 plus n minus 1 times d. Remember, when you write an explicit formula, then you want to leave that in terms of n. So we're going to leave those alone. So that's going to be a sub n is equal to my first term, which was 3, plus n minus 1 times my difference that I found from up here. It has a difference of 4. Okay, so d is equal to 4 here. 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4. Makes sense because we were adding 4 each time, weren't we? So a sub n is equal to 3 plus 4n minus 4. So my explicit formula is a sub n is equal to 4n minus 1. So here you need to see the difference between an explicit formula and a recursive formula. Okay? Again, a recursive formula, with a recursive formula, you can only get your next term if you know your previous term. That's the only way you can get it. But with an explicit formula, then you can find any term that you want. You know, if I want to know the 1000th term, I would just plug in 1000 for n, and I would be done. But with a recursive, if I wanted to know the 1000th term, I would have to know the 999th term first. Okay? So, let's look at this one. It says, find the next 3 terms if a sub 1 is 64 and a sub n is 1/2 a sub n minus 1. So again, we're looking for a sub 2, a sub 3, and a sub 4. So that's going to be half of, if I'm putting the 2 in the place of n here, then I have to put a 2 in the place of n there, so that's going to be half of a sub 2 minus 1. So that's half of a sub 1. And a sub 1 is 64. So that means a sub 2 is 32. So with this recursive formula, the only way I can get my second term is if I know my first one. And again, here, the only way I can get my third term is if I know my second one. Because if I want to find a sub 3, I'm putting the 3 here, which means I have to put a 3 there. So that is a sub 3 equals 1/2 a sub 3 minus 1. So a sub 3 is equal to half of a sub 2. We just found a sub 2 to be 32. So a sub 3 is equal to 16. And again, the only way I knew I could figure out the third term was if I knew the second one. Okay? And by now you can figure out that a sub 4 is going to be 8, because what we're doing is we've started with 64, we've gone to 32, then 16, and then 8, so you can tell that we're taking half each time. So our common ratio is 1/2. So this is a geometric. Okay? Well, if this is geometric and I need to find an explicit formula now, then that means I'm going to use a sub n is equal to a sub 1 times r raised to the n minus 1. Going to leave our n's in there. But our first term is 64 times our common ratio is 1/2 raised to the n minus 1. And I'm going to do with this what I did a while ago. I'm going to separate this and get this in the form of an exponential function. So here we go again, if you didn't quite get it the first time. To split my exponent, I just put 1/2 n at the top divided by 1/2 to the first at the bottom. Okay, that's your law of exponents. If you are dividing like bases, you subtract exponents. Okay, so if I were dividing these out, I'd get 1/2 to the n minus 1. So I'm going backwards and I'm splitting it up. So a sub n is equal to 64 divided by 1/2, which is not 32. It is actually 128. And then bring down the 1/2 n, and that is your explicit formula for that recursive function. Okay, last one is I'm going to give you a sequence and you're going to write a recursive definition. So remember, you've got two parts. You have to say that your first, your initial condition is where are you starting. I'm starting with my first term, a sub 1 at 81. And then I'm going to write a recursive formula. I'm going to say, well, to get my next term, a sub n, okay, what do I have to do to my previous term? And my previous term, so my previous term is 81. That is my a sub n minus 1. So to get your formula, you just have to ask yourself, well, what am I doing to 81 in order to get 27? Well, you're going to be taking 1/3 of it, or dividing by 3. And the way you can tell that is you can say, ask yourself, well, what, do the whole previous minus, the whole next minus previous, or next divided by previous. I can tell that if I try to subtract these, I'm not going to get the same thing every time. But if I divide, I am. 27 over 81 gives me 1/3. 9 over 27 is 1/3. 3 over 9 is 1/3. So what I'm doing is I'm multiplying this term, 81, by 1/3, and that gives me 27. And then if I take 27 and multiply it by 1/3, that's going to give me 9. And if I take 9 and multiply it by 1/3, that's going to give me 3. So what I'm doing is I'm taking my previous term, which is a sub n minus 1. Okay, so each of, sorry about that phone call. The previous term is being multiplied by 1/3 to get the next term. So again, this is your previous term. This is your next one. So I'm having to take my previous term and multiply it by 1/3 to get my next one. And we write that a little bit better simply by putting that 1/3 in front of a sub n minus 1. Okay? So your recursive formula, I can actually write that better than that. You would write your initial condition first, and then a nice pretty little recursive formula underneath it as 1/3 a to the n minus 1. So you actually want it to look like this. Okay? So that is all there is to recursive and explicit formulas for arithmetic and geometric sequences. If you have any questions, you know to ask. Have a good day.